My name is Charan Sirpa. Yeah, my name is Charan Sirpa. I'm currently working at KaptureCX as a tech lead in data platform team. So my work mostly involves real-time distributed systems like Kafka, ClickHouse, StarRocks DB, and a couple of other distributed systems. So a little bit about KaptureCX. KaptureCX is mainly into customer support automation platform, and we have clients which is into different segments: e-commerce, quick commerce, um, healthcare, and finance. Right. So, me and team approach challenge migrating from all the dashboards and reports to any analytical database, right? Initially, we started with the ClickHouse, right? ClickHouse is a great database. It's a modern analytical queries. It can handle millions of records aggregations in a millisecond. We use ClickHouse extensively in other segments where in which data is immutable, like click events, like application logs. We all use ClickHouse in those cases. But when it comes to ticket, so there is a lot of one ticket goes into different mutations, right? So an example, once you raise a ticket, right? Tickets should be first created, then it goes to the queue, right? And then it would be assigned to some agent, and then agent will again redirect to some other agent through the queue, or it can be junked, it can be closed, it can be completed. So there are a lot many transitions happens on a single record. So but it's I could say it's a heavy absurd requirement. But when it comes to ClickHouse, we have a table engines in the ClickHouse. If you might have heard merge tree, replacing merge tree, and aggregation tree. We have used this replacing merge tree in wherein which if you insert couple of records with the same key, right? It will it will pick the final one based on the order key, right? I'll show you the example. So this is the example wherein which you create the table with the replacing merge tree, right? But the problem is every time you want to access the data, you have to use the final keyword. Like let's select start from profiles and use the final. So these final statement will picks the latest record of that particular key based on the order. If you see replacing merge tree and the based on the version column. So record with the highest version with the same key would be picked, right? But this is very much CPU intensive, right? And there are lot of duplicates in it, and we have to run the manually compaction job merge command to basically remove the duplicates. And we used to run this periodically to remove the duplicates. And the moment we run that merge command, CPU used to spike to 100%, right? So in heavy updates, ClickHouse was not working in our case, right? So and one more thing is, as I told you, our customers are into different segments, right? One is into e-commerce, quick commerce, and other segments. Not a single schema or a single dashboard and report can be served to all the clients, as they are into different segments, right? So our requirements are quite dynamic. It's not that I'll pick a complete schema in a single table and do the flat table and serve everything from that table. No. So requirements are dynamic. We needs heavy joins. We do heavy joins on a different tables based on the requirement. But when it comes to joins, ClickHouse was not that great in terms in joining. So we saw a lot many performance issues in the joins as well. And the main was real time. So there are a lot of duplicates. As I said, we used to run merge command on a periodical basis. And the moment you run the merge command, CPU used to spike to 100%, right? So and other thing, ClickHouse doesn't have uh, you know uh, query optimization. It's a bare metal query engine, which when once you fire a query, it directly dumps the query in a against that all the packet files with a vector execution. Right? There is no sort of uh, uh, query planning or something. Right? So that's one drawback wherein which we are unable to use the ClickHouse here. Then now again ClickHouse failed in this use case in our case, but we tried different databases which are available in the market, and we got to know that about StarRocks DB. StarRocks DB is basically a distributed system, and which before starting with the StarRocks, I'll explain you the architecture, how it looks. So StarRocks is a analytical database where you can run all the analytical sort of queries, and it will serve in milliseconds, right? So a little bit architecture of StarRocks, how it looks. So StarRocks has two major components. One is the FE node and BE node. FE stands for front end node, BE stands for the backend nodes. And there are two architectures. One is the shared nothing architecture and the shared architecture. First, I'll be focusing on the shared nothing architecture, wherein which all the FE nodes are responsible for handling all the client queries. If you run select statement, insert statement, any sort of client connection, first everything would be served from the FE nodes. And uh, this is the main brain of entire StarRocks architecture, right? So it is distributed. You can have a couple of FE nodes wherein which one would be the leader and other would be the followers and observers, right? And when it comes to the B node, B stands for the backend node, wherein which the two main roles and responsibility of these backend nodes are to store the data, and one other one is the execution engine. So basically, once I run select count star from any particular table, it goes to the FE, and FE will basically schedules the query on one of the B node based on some query optimizations and logics, right? And B is the one which execute that particular query, get the data from the storage engine, and returns data to the FE, and ideally FE will return to the client. So I guess it's clear, right? If you have any questions, you can interrupt me in between. Yeah. Yes. Yes. So absurds, yeah. Yes, I'll blindly use ClickHouse because uh, uh, in terms of click events or application logs, like we rely heavily on ClickHouse for all the application logs, right? We generate around 250K per 250K per second events in for all the application logs, and we dump them directly to the ClickHouse.
Okay.
Yeah.
So if you start using, let's say, this one for other applications also immutable, then what happens? Like
it works. It works.
It works.
Yeah.
So that means that if we can replace all ClickHouse workloads with
Yes,
this one.
can. Yeah.
Okay.
So it has its own advantages. ClickHouse has its own advantages.
Okay. Where ClickHouse shines compared to StarRocks? Because you said this is for my understanding.
Yeah.
So you said like you can do everything what ClickHouse is doing with the StarRocks. So then we can replace everything with the StarRocks, right? So is there any area where ClickHouse also shines? Because ClickHouse also used by many people, right?
Yes.
So just curious to understand.
So let's assume I'm building a system which it collects metrics, right? And where timestamp based data, like just like Prometheus, it's a time series database, right? So same ClickHouse has time series, works well for the time series data and works well for, it's mainly also for compression.
Okay.
Compression is the one thing, and query execution, it's very faster. It's very faster.
ClickHouse is
yes.
Okay. Okay.
All the modern databases are mainly focus into vector execution.
Vector,
like,
yeah.
There is a thing called SIMD.
Yeah.
Yeah.
So both supports the ingestion also, like millions of events. ClickHouse supports, I think.
Yes. So one major difference between ClickHouse and StarRocks was there is if you want to load the data from Kafka, right? ClickHouse has its own ingestion,
Correct.
and StarRocks has its own ingestion. But StarRocks ingestion is cron based, right? It basically cron based.
Cron based, incremental type.
Periodically, it will run the consumers, it dump the data. But when it comes to the Kafka, it's a continuous daemon ingestion.
ClickHouse is
yeah.
Continuous.
Continuous.
And this is like an incremental batch type.
Yes. Yes.
Okay.
It basically stores how much data, what all the offsets we have consumed, and in the next periodical cron, FE will decide which B to execute, what sort of consumer would be consumed by which B. So it's scheduled based. But in terms of ClickHouse, it's a daemon which is running behind the scenes.
Yeah, continuously.
Yes, continuously.
It's like a Kafka consumer.
Yes.
Okay. So this, how much is the delay, like the batch size?
You mean
in ClickHouse you mentioned it's a continuous.
Yes,
like
yes.
once
We
within
can
a
configure
second.
it, but minimum is the 5 seconds here.
Minimum 5 seconds.
Yes.
Okay, but in ClickHouse, I think it's less than 1
Continuous. Yeah,
second.
you can visible data in like lightning fast. The moment you generate data to the Kafka,
query
it will
is
be,
ready.
yeah. See,
But here it is a minimum 5 seconds.
Yes.
So what is the optimum? Like how much time you use for the batching?
5 seconds.
5 seconds.
5 seconds.
Okay.
Yeah.
So this is also one of the point we need to consider.
Yes.
When we are choosing between ClickHouse and this one.
If you have a immutable data, if you need millisecond refresh data, then use ClickHouse.
Okay.
Yeah.
And joins should not be there. It's a denormalized data.
Yeah.
Okay.
So in our requirement, we heavily rely on joins, right? Our schema is not fixed. We on an average we use 5 to 6 table joins for a single dashboard query or something.
Okay.
So for joining all those tables, ClickHouse is not that great.
Okay.
If you have heavy absurd requirement and joins, better use ClickHouse.
StarRocks.
Sorry, my bad, StarRocks.
Yeah. And ClickHouse, when you have very, then when should you use ClickHouse? Still, I'm not clear.
You don't have requirement of joins and upserts, you can use ClickHouse.
But is there a use case where you're still using ClickHouse?
Yes.
Okay.
For the application logs, for all the metrics we collect from our infrastructure, and we have a VoiceBot, and all the transcription which happens, it's nothing but application logs.
Right.
We directly dump all the, we have around hundreds of machines wherein which we install the FluentBit agent, which collects the log from the applications and send to Kafka. And from Kafka, we directly dump them to ClickHouse.
So for your customer support tickets, currently you're using which one?
StarRocks. Yeah.
Which one? Shared nothing or shared data?
Shared nothing.
Shared nothing.
Yeah. The reason being, I'll explain.
Right.
So, yes. Indexes. Yes.
Similar indexes. Okay. So like ngram, like full text search.
Yeah. It
so
the one thing is, as I told you, if you have updates, right? StarRocks has a table engine called primary key engine, wherein which if you insert multiple records with the same key, it automatically deletes the previous records behind the scenes. We don't need to run the manual merge command to basically remove the duplicates.
Okay.
It doesn't.
So
have
deduplication.
Sort of.
It will do automatic deduplication.
Yes, basically, yeah. Automatic deduplication. And in ClickHouse, we need to run the compaction job sort of query.
Okay. So that is where you mentioned
yes,
it takes
CPU,
like
yeah.
CPU.
Yeah. As I told you, a single ticket transitions happens into 15 mutations, right? So 15 updates happens on a single row, and we generate millions of tickets on a daily basis. So there is a heavy absurd requirement in our case, right? That's where in which we use primary key table in the StarRocks. We initially started with the ClickHouse. Then the next one was the StarRocks. It worked well in our case, and the reason it worked well, everything is in the checklist got checked. The only one thing which missed from the Pino was it's our use case. So all our internal microservices are majorly relied on MySQL, right? All the microservices which are responsible for generating the dashboards data or serving the reports, they are mainly on MySQL, right? And StarRocks is MySQL compatible, right? The way you connect to the database, StarRocks database, is same as how you connect to the MySQL database. Exactly. Yeah. So it's a simple domain change of that particular. Yes. Application would be the same. Just we need to change the domain in the env of a host. Yeah. Yes. Yeah. That's one more major reason we didn't try Apache Pino. It's also great, but we didn't get a chance to look into more because it served all the requirement for us in this case. Yeah.
Do you have a tied storage in this? Because the data you said like it's very high data. So quickly it will fill up all the nodes, right? So do you have some mechanism to push the old data to tied storage, like object storage or something like that?
So as of now, I don't know how industry does this, but me and my team, we manually run the jobs wherein which we dump the stale data, basically
Old
old
data.
data, to the TL storage. And if as of now, we mostly dump into iceberg tables, and again we query them through StarRocks only.
Okay. So it supports both internal storage as well as the iceberg external tables.
Yeah, it can be used as a query engine for iceberg,
For both.
just like Trino or other iceberg native query engines.
So in a sense, it is supporting, but you are doing manual step of doing dumping into iceberg.
Even ClickHouse has also released its query engine support for iceberg.
So in a sense, like you can have infinite data query, like times.
Yeah.
So like 1 year, 2 years old data also you
as
can.
of now, we have 1 year data in StarRocks cluster as of now, and we have around 150 tables migrated.
But it will be little bit slower when you are running on iceberg, right?
Yes,
Because external table loading and
that is the reason why we use shared nothing architecture instead of shared data. Yeah, as I told you, the shared nothing architecture has a B nodes wherein which each and every B is responsible for storing the data. Right, but when it comes to the shared data architecture, instead of B, there is this component called CN, which are compute nodes. Right, it's the main responsibility of the CN nodes is to run the query based on pull the data from the S3 or any tier storage, S3 or SDFS. Yeah, S3 basically tier storage, and it will pull the data from the S3. It runs data on top of the Parquet files and return the result to FE.
So you are using both because
in this case we use
But the old iceberg table.
Yeah, we can directly query from here as well.
Okay. Yeah.
Initial major real-time dashboards, quick real-time dashboards mainly served from this architecture. This doesn't talk to us. It can also talk to iceberg, but data is stored in
local.
Can be stored in
SSD.
B nodes as well, SSD basically. And if you have any tables which are stored in iceberg, you can also query that. But in this case, CN node doesn't store any data in these nodes. These nodes are only responsible for running the queries, query execution. Yes, yeah. If you have data already on iceberg, you can directly use this. Right. The way we before that, in I guess the architecture is clear. Why shared nothing and shared data, right? So now in shared nothing architecture, we use B nodes, and table in StarRocks is nothing but a logical entity, right? All the metadata of the table is stored in the FE node. As I told you, this is the main brain of the entire StarRocks cluster. And B nodes store the data. It works on MPP architecture, massive parallelism. How it achieves the massive parallelism is by distributing the single table data into multiple B nodes, right? So the moment you create the table, basically first FE nodes store the metadata of that particular table, and data is distributed into multiple B nodes. And if you run any aggregation queries on top of that data, so basically query is distributed into all these B nodes, corresponding B nodes, and it will that's how it throws the query into multiple nodes and get the data. That's why it's fast. It relies on MPP architecture. But now, how does it distributes, right? So in based on the hash, it basically distributes data to different B nodes. That hash is nothing but a bucket. It's called as bucketing in StarRocks, wherein which we define it based on the table creation. That's I'll show. So this table, audit logs, if you could see line number 26, it's a primary key table of ID and distributed by hash ID. So in our case, we mainly rely on customer ID. We name it as a CM ID, as a customer ID, right? And distributed by hash, if I do CM ID, basically all the data of that particular table would be stored in a single B node, right? So if I want a count of that particular table where CM ID equals to 1, 2, 3, and FE knows table is distributed based on the CM ID, right? So the query goes to the exact B node, not to any other node, right? Yes. 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 As of now, we saw the same. We have a large chunk of data of two particular clients, and we saw this going into the same B node. We are trying to resolve it as of now. My team is working on it. One way is to alter, increase the bucket and increase the B nodes. Right? The moment you change the bucketing key with number of buckets and increase more B nodes, and it will automatically be distributed to different nodes. So his question was, let's assume, as I told you, it's based on CMID, it will distribute data to different B nodes. His question was, what if the major data of a particular client, wherein which the volume was very high. So there is a customer ID C1 and C2, which data count is very huge. There can be chances where these two data goes into the single B node, right? And it ideally be choking the database, that particular node, and it will use a more resource and SSD as well. So as of now, we are working on the same. The one way is to increase the B nodes, as I explained you. One way is to increase the B nodes and alter the table and increase the bucketing, right? As of now, we use 32 buckets. If I increase the bucketing system, it's gonna be distributing to multiple nodes, right? That's one way where we can distribute, alter the table, right? And yes, yeah. Yeah. Yeah, and one more thing is CBO optimizer, which is called cost-based optimizer, right? So once you execute any query, as I told you, the first facing is the FE nodes, and FE nodes basically decides where should this query goes, and also at the same time, if you have 10 different joints, it will prepare a plan. It will prepare a query plan and decides which table should be queried first, right? So this CBO optimizer is mainly used for joins. If I let's assume there are 4 different tables, and one table has a minimal data, which is the main table, right? Basically, automatically FE detects this is the first table that needs to be picked and apply joins on different tables, right? So this cost-based optimizer is there in StarRocks. That is a one major thing major checklist for the StarRocks, right? So as I've explained what all the table types, it has primary key table wherein which automatically duplicates will be removed and the latest data is served. And we have duplicates table wherein which we mention just order by, right? There is, if you insert multiple records with the same data, it will keep all those copies of that particular data and based on the order key, right? And aggregation engine, same as ClickHouse, it aggregates basically, yes, please. Not only a load balancer, it also decides which B should be responsible, which backend node is responsible for executing that data. Yes, query planning, query parsing, query planning, query optimization, yes, cost-based optimization and scheduling Kafka consumers on a B nodes, all these responsible would be applied to FE nodes. Yeah. Yes, please. So there is a leader action going on between the FE nodes, right? Any one FE is a leader and other one is followers. If that leader goes down, and again leader action comes into the picture, and one of the node would be picked as a leader. Fine. So then the routing node, as I told you, if you have data on a Kafka, and if you want to ingest, you don't need to manually run any code to ingest. It has an inbuilt Kafka consumer. It loads data from Kafka. It also has different sort of loads, wherein which if you have data on S3 or tier storage in a Parquet format or any other format, you can directly dump those data from tier storage to StarRocks. So that is a one major advantage. And as I told you, we heavily rely on MySQL on application level, so it's a MySQL compatible. The way you connect to the StarRocks is same as MySQL, right? And the one major thing is a collocate join. So this is the best thing within the StarRocks. So as I told you, if I create a table, if I insert data of multiple customers, the same customer data is sent into one B node. That's how it distributes, right? So let's assume I have 3 different joins and 3 B tables, and have three different tables, and table 1 data is stored in B1, table 2 data can be stored in B2, and table 3 data can be stored in B3, right? But when I run a query with all three table joins, right? But any one B node is only responsible to run those joins, right? And FE will, based on the resource, based on some other parameters, FE schedules that particular join query on any particular node. Yes. Yes, yes, yeah, yeah. So as I told you, we use bucketing because any all for a particular T1 table, all same customer data would be stored in a single B node, right? If T2 table is stored in here and T3 table of data is stored in here for same customers. But when I apply join, let's assume B1 node is running that particular join, it needs to load data from BE2 and BE3. Why? Because we have a couple of joins, right? And there is a network hop in between, right? So it again increases latency, right? So that's the we have an option in ClickHouse, sorry, StarRocks, wherein which we can use collocate joins. The moment you use collocate group, so we apply collocate group on multiple tables, right? So what happens once you create table and insert some data? So all the tables which are having the collocate group will be storing the same data of all the tables of a particular client in a single B node. So let's assume client C1 have 5 tables, and all the 5 tables data of that particular client will be stored in only single node, right? So in that case, my B while executing the join operations, it doesn't need to pull data from other B nodes, right? So that is a one major advantage, wherein which you can, if you have 10 table joins, and if you apply collocate a group on those particular tables, and all data execution happens in a single B node, it doesn't depend upon data on multiple nodes. So that's a major advantage. So as I told you, we rely mainly on joins. That is a major advantage we saw in query optimization. No, it's based on hashing, as I told you. And if you apply group, if you apply collocate group on top of it, it ensures that all same key of a different tables would be stored in a same B.
This groups has to be.
Yes. Basically, sort of filters. This is not a but list of, yeah. So that yes, as I told you initially, we also rely on reports, right? Initially, it used to take 15 to 20 minutes to download the report from legacy MySQL, right? No, granular level records. That's we have automated scheduled reports on StarRocks as well for different clients. It worked well in our case. Yeah. List. Yeah. 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 No, no, it's not that number of FE and B nodes should be equal. No. If you want to auto scale, you can directly increase the B nodes to, yeah. And FE nodes you can increase in terms of heavy queries like client queries, client query count is large, you can directly auto scale the FE nodes. Yes, please. Yes. Yeah, it works. Yes, please.
These groups you told, right?
Yes, collocate.
These have to be declared at the schema time itself?
Yes.
Okay. So you need to know which queries.
Yeah. As I told you, our system is a multi-tenant system, right? And all the queries happens and all the joins happens with a on a customer key, right? We know which is the main key which is used in the joins in every table. So client key is fixed that we're gonna use this client key on a joins on every table. So we in that's why we distributed data based on that particular key, and also we applied same on the collocate group.
What if you decide to do joins
on the separate on a different key in future? Can that be then?
Yes. So as I told you, the hashing bucketing technique, right? Bucketing can be on a single column, or or it can be combination of multiple columns. So based on the query needs, you have to alter your table.
Okay.
Yeah.
Initially, you told 1B per client. Then
Not. So
based on ID, you told right,
Yeah.
1B is per client. Then why you distributed one client data on 3 different B and later to join?
No, tables are distributed into all the Bs, but segment of particular table. So one client segment of particular table would be stored in a single B. Let's assume a table clients, client tickets or something, wherein which we have every client data, but we bifurcate based on the client ID, right? So a single client ID, similar client ID group of records would be stored in a single bay. If a customer ID is 123, all the records with the 123 would be stored in a single bay, and another 124 can be stored in other, and 125 can be stored here, right? So it's a small segment of that particular table is stored in a single node. It's not that I'm distributing it. In our case, we use 5 FE and 6 B nodes. As of now, we doesn't auto scale as of now, but in case if load comes, we're gonna increase. The best way to auto scale is just you increase the B nodes. That's it. Once you increase the B nodes, you need to register that B node in the FE, right? You can detach, you can attach any sort of backend nodes in the FE.
Number of queries per second.
Number of queries per second.
Like for example, if I use a Databricks cluster, it supports 10 queries at a time, like parallel. So like if I take
1,000 queries in a concurrency, we're able to query as of now.
1,000.
Yeah, because we are backend services not only the services which is querying the database. So we build this in-house tool like Metabase. Right? If you might have heard Metabase, it's a quick building dashboards based on the data, right? So we expose that data to our internal system, which is embedded into the client UI. Client themselves can query the data and build the dashboards.
So like it's 100,000 queries per second.
Yes. So all the checklists got checked. We got to know that StarRocks is the right database in our case to use because of all these major things, right? But now one more major issue was how do you migrate data from legacy MySQL to StarRocks, right? It's a big issue. And the one I approach is to write manual ETL pipelines on a batch system, right? Based on updated it or created it, you basically store that offset as updated, and a cron basis you can run the ETL pipelines to generate data to it. But again, we need something real time, right? So ETL pipelines, manual ETL pipelines cannot be that fault tolerant, right? And we need some component called stream processing system in between, which sits in between MySQL and StarRocks to transfer data in a real time, right? So initially we thought of using Debezium directly, but the problem with the Debezium is it's a simple, it's a CDC sort of thing. It connects to your val or bin log in case of MySQL, val in case of Postgres. It pulls the data and push to Kafka, and StarRocks would be consuming data from that routine load. But my initial thing was, as we are completely new to StarRocks, let's in case of any crash of StarRocks node, something happens to the StarRocks cluster, but we want to replay the data very soon, not 2 days or 3 days, right? We want data to be replicated, dumped in couple of minutes, right? In case of any crash in StarRocks. So we need something persistence in between, and also at the same time as a stream processing, right? So that's where in which we came across a database called RisingWave. So RisingWave is basically, it's like a stream processing system. It's a Flink alternate, right? It's built on Rust, So it's highly concurrency and heavily optimized. And the one more major reason was it stores data in S3. Right? If you once you connect to the bin log, it will basically it can it's a middle component between which connect to the source and destination. It pulls the data from the source and it stores it and it can publish to any destinations. Yes, there are multiple connectors. Kafka. Yes. Kafka, MySQL, Postgres, and couple of other sources. No. CDC.
Kafka in between.
We basically RisingWave sits in between, right? It pulls the data from MySQL through bin log,
Okay.
and it will publish data to any other sources. It can
So
be
let's say I'm getting data from MySQL.
yes.
So then normally what we do is CDC and then we push it to the Kafka and then do ETL from there and then put it to warehouse or whatever like analytical databases. But in this case, if I am using RisingWave, I don't need Kafka in between. I still need Kafka.
No.
I don't need.
No. Just like a Flink, it's not mandatory that use of Flink with Kafka, right? So it stores intermediately, and it can you can apply joins, streaming joins, windowing sort of joins in RisingWave, and it's there is a checkpointing, so which is happens in the back behind the scenes for crash recovery, and it's very easy to auto scale. There is this component called compute nodes, which is responsible for running all these CDC things. The way you auto scale is just to increase the number of compute nodes, it automatically auto scales.
Okay.
Yeah, and it's easy to install. So our main focus was on StarRocks. We don't need to leave the StarRocks and setting to fix the middle thing.
Okay. So the reason why I asked is like there can be some situations where the spiky load can come. So in CDC in MySQL there is a sudden CDC change event.
Yes.
So if I am not processing in that speed, then I will be losing that events, right? So that is why we generally use buffering as a Kafka. So in this case, RisingWave will absorb that spikes.
RisingWave is also mainly depends upon the LSM trees. It's append only sort of thing.
Correct.
Right? So it's very fast.
Okay.
Yeah. You can it's like source, materialized views, and sync. In materialized views, you can join multiple tables, like streaming joins, right? And you sync to any different destinations. It can be Iceberg. It's mainly on Iceberg native as well. You can directly dump data to Iceberg format as well through RisingWave, right?
And SQL.
Yeah. Yes. And so we have an entire setup of RisingWave, StarRocks was deployed on Kubernetes through Helm package. So that is an easy way to install something on the Kubernetes. And our team has expertise on Kubernetes, so that's why entire workload is on Kubernetes. We have a dedicated cluster in which we have StarRocks and also at the same time RisingWave nodes working on the same cluster.
So both you are using managed service or the open source?
Open source.
Both are open source.
Yes, everything is open source.
Okay.
Yeah. We have around in our case, RisingWave is connected to not only to MySQL, it loads data from MongoDB, it loads data from PostgreSQL and other couple of sources.
So live events?
Yes, live events. CDC. Yeah.
CDC, not CDC. Like you said, like web events and
all CDC events.
CDC.
We replay it through RisingWave. So what happened in between? From RisingWave, when we are trying to insert data directly to StarRocks through MySQL destination, right? But we used in between there is because of some network lag or some high concurrency, we saw some drop of events in this StarRocks cluster, right? So what we did, instead of dumping data directly to the StarRocks, we introduced Kafka buffer in between. Right? Yes, RisingWave and StarRocks. Yes, data first is the MySQL, then RisingWave, then Kafka. Right? As everyone knows, Kafka is very highly ingestion system. It can directly RisingWave will directly ingest data to Kafka. And StarRocks has, I explained, there is a routine load. right? That routine load would be running in the cron basis periodically to pull data from that particular topic and ingest data to corresponding tables in the StarRocks. So something happens to the StarRocks, crash, down, failure, hardware failure, or anything, we can directly replay events from RisingWave directly. So as I told you, if you use Debezium in this case, Debezium is a system where it directly pushes data to the Kafka. It doesn't store intermediately, right? So if I use Debezium in between, and if something happens to the destination downstream system, I have to replay all the events from MySQL. Right? We don't generally do that in the daytime as we have production workloads running on the MySQL. Yes, yes. So for real-time RisingWave, for real-time dashboards, in trading systems or something, it doesn't mainly relies on the historical data. Yes, yes. For all the historical records and joins taking into the consideration, we use this to StarRocks. Yeah. Yes. If you create materialized view, it doesn't ingest data from the start. The moment you create materialized view, from that particular timestamp, it starts joining. Yes, exactly. Yes. Complete, yeah. As I told you, we have different requirements. We need to join multiple tables dynamically. We can't directly use MVs, RisingWave MVs. Yes. So if I use Flink, I want data to be stored in some tier storage also, and which can be easily deployable, right? And the one major thing from RisingWave, we can directly connect to the RisingWave and run the queries. The way you run the PostgreSQL. And just like StarRocks, it's a MySQL compatible. Same RisingWave, it's a PostgreSQL compatible. The way you connect to the Postgres database is the same that you connect to the RisingWave.
How many days of data? How many days of data? How many days of data you have in RisingWave?
There is no retention as of now.
There is no
as it stores in S3, we don't have any issues.
So you are directly storing in S3.
Yeah.
So
there is no intermediate data or SSD in RisingWave. No. Yeah. But how do you dump data from SQL binlog to Kafka? Debezium. But RisingWave internally uses Debezium. It's not that it wrote from scratch, replaying the events from all the databases. They use Debezium engine and integrated their system on top of Rust. Yeah. So this is the final flow. Data would be first, the data source is a MySQL, then to RisingWave, then to Kafka, then to StarRocks routine load. So this is the flow of data which happens. And as I told you initially, the reports and dashboards were served through MySQL legacy databases. Dashboard used to load in 20-30 seconds, right? After migrating data to StarRocks, all the dashboards and would be loaded in milliseconds, right? In a couple of seconds. And the query execution time is in milliseconds. All because of MPP architecture of the StarRocks and collocate joins and MySQL compatible and vectorized query engine, right? So it's not only we use reports and dashboards for StarRocks. We completely our organization built completely agentic data plane on top of StarRocks. StarRocks, wherein which we have internal system which has a LLM and couple of MCP servers directly running the query on the StarRocks, getting the data and handing it over to the LLM. Right. So agentic data plane, reports, dashboards were completely automated through StarRocks DB. And initially, MySQL, we used to dynamically, manually UI and backend teams are involved in building the dashboards. But as we migrated everything to StarRocks, we used a concept of views, right? In any databases, view is nothing but a couple of select statements with the joins. We group them into a single view, right? And you directly assume that view as a table, right? Let me show. So if you see, this is a view which has a select statement and couple of tables, right? If you could see 1000684, it's a single client data of all these tables. Okay, and I create user based on the client, right? If XYZ is a client, we create all the views based on the schema, and we dump that all entire joins in a single view, and that user can be accessed only to that particular view, not all the tables, to the view. And as I told you, we have built something like metabase in-house. We directly connect those views to the client, and client can directly run those queries on top of view, but it's not a table. Under the hood, it's a joins of multiple tables. If so requirement comes this way, if product comes up with the different dashboards and metrics, and my team would be directly running those queries, grouping them into a single view and provide access to that particular client. That's how we automate everything. So initially it used to take weeks to deliver dashboards and reports. Now it's within one day we could deliver all the requirements. Yeah. That's from my end. If you have any questions, you can shoot it out, else we can mind this. Yes, please. Yeah. So,
yes, RisingWave before Kafka. This one is
RisingWave before Kafka, but some component needs to be involved in replicating data to from Winlock to Kafka, right? So RisingWave has Debian engine inbuilt, so that's why we have directly used RisingWave here. And also S3 checkpointing is the main reason we use RisingWave. The one issue we saw was binlog files used to purge before StarRocks consuming that particular files. So we have auto scaled that compute nodes, as I've told you in RisingWave. That's how we auto scaled and increase the concurrency of that binlog.
so there is no bottleneck you're facing.
Yes, no,
Correct.
not as well. Yeah. Any questions? Yeah. Thank you so much.